All right, so let's say you're given this integral here, and the question wants you to compute the integral. Now, first looking at this integral, it's not obvious how to solve since the variable x appears twice in the integral. Using traditional methods, it's not exactly clear how to compute it. To compute this integral, we need to apply an integration technique called integration by parts, which can also be referred to as the reverse product rule, which is given by this form here, where u and dv are the two functions we identify in the function we're given. So the first step to solve is to first pick what u is. This is the part you want to differentiate. Then we pick dv, which is the part that we can easily integrate. Step 3 is to compute du and v from these two quantities we identified in 1 and 2. Step 4 is just to plug it all in and simplify. The first note I want to make is that integration by parts is used when the integrand, which is the function we want to take the integral of, is a product of two functions, and one of these functions becomes simpler when you differentiate. The second note is an easy way to figure out how to choose u is to use this expression called liat, which liat stands for this here. And if we number these, what we do is we pick the earliest one as u that shows up in the integral. If we apply this to our example, this is our example here, and this is our integration by parts equation. The first step is to pick u, which is the part we want to differentiate. Look at our integral here. It's going to be x, because this is the part that's causing us problems when we're taking the integral. We want to differentiate this. Now we can pick dv, which is the part we can integrate easily. If we look at our integral, it's going to be ex dx. Since we know that the integral of ex dx is just ex, it's an easy integral to compute. From here, we can compute du and v. Identify that u is equal to x, so the derivative of u with respect to dx is actually going to be equal to dx. I put 1 because I forgot about the chain rule. Sorry about that, guys. It should be equal to dx. We can find v by taking the integral of both sides of this expression. So the integral of dv is just v, and the integral of e dx we found earlier, it's just e to the x. So we can plug all these values in, and if we do that, I just noticed the error I made earlier with the du actually equaling dx. We have this expression here. We can do this simple integration of e to the x dx, which is just e to the x. And if we plug that in, we get this final answer here. So this is the final answer for the integral using integration by parts.